Now I already given that this is the basic equations you require to remember, that V is equal to IR, very simple Ohm's law. P is equal to VR is also from this equation, and P is equal to I square R. Then after voltage across inductance, because in case of circuit we have three basic elements, that inductance, resistance and capacitance. So for inductance we have the voltage VL, that is LdI by dt, that last time we already discussed. Now current, from this equation we have the current equation, that also we can discuss, that IL is equal to, integrate this equation, then we will get IL. Yeah. Now this is also fundamental equations. Now there are different types of network also. I've already given. I'm just going through this classification of network. So first we have discussed linearity, linear network. Now a linear network, that also we have already discussed, but those who are new, types of network. Now this is the basic type of network. That first is linear network. The property of this linear network is known as linearity. Linearity. That means if we give the voltage to the circuit, suppose we have this circuit like this. Say this is the okay. Now this is the circuit. This is circuit. Okay. This is the basic circuit. Now if we applied here is suppose one voltage Vs, and I am connecting another voltage. Suppose I am connecting here is the V2. This is suppose V1 and V2. So here also that instead of V1 I am written is even. So when we applied this both voltage simultaneously with this, if I am applying both the voltage simultaneously, then what happened, that the current in, suppose I want to find out current in this branch. So current in this branch, which is given by the current supplied by this voltage as well as this voltage, resultant of this voltage will supply current I into the circuit, this circuit. Now the basic concept is, when we applied L1, suppose when we applied V1, that is when we applied the first voltage, by keeping this voltage short circuit, this voltage is, we have to remove this voltage and find out current in this branch. That current is known as I1. Suppose this current is known as I1 dash. Because of only V1 voltage, current is I1 in this case. Now second case, if we apply, if we connect V2 only with V1 short circuited, I am shorting this, I am removing this voltage source with the short circuit. So that voltage is, that current is known as I2 dash. I1 dash, I1 double dash. Okay, this is I1 dash and this is I1 double dash. Now the resultant current I, that is given by I1 dash plus this I1 double dash, right? This is I1 double dash and this is I dash. Means the resultant of this two will give the total current I, right? That means the voltage, if we apply total voltage, if we apply both the voltage simultaneously, then what happened, the current I, which is equal to I. So suppose this is 5, for example, this current is 5 ampere. So which is given by the resultant of this two, algebraic sum of the current of, with the voltage source V1, current is I1 dash, with the voltage source V2, current is I1 double dash. So resultant of this is known as I. So this is known as superposition theorem, superposition property. So I can say that this is, suppose with the even, your source means I1 dash. Your, this is the source and this is the response. Sorry, this is the response, this is the source. With the source V1, your response is I1 dash. Here is also with the source of E1, your response is C1. And with the source E2, your response is C2. Now if we sum up this voltage E1 plus E2 simultaneously, if we are giving, the response is given by C1 plus C2. That's also already I have discussed. I is equal to I1 plus I2 when the both voltages are applied. So when both voltages are applied, so this is the given by the same thing here I have discussed, that with even source only, response is C1T, with E2 is short circuit. Now second case, when we applied E2, E1 is short circuited and the response is C2. So we'll get C1 plus C2, which is equal to the total response given by E1 plus C2. It means that when we say this circuit is linear, it means that it doesn't depends upon it doesn't follow the law of superposition theorem. Then it is known as non-linear circuit, and it follows the superposition theorem, superposition principle. What is superposition principle? That it means that when we applied even the supply is I1, source is I1. When we applied V2, source is I2 dash, I1 dash L dash, and summation of this will give the total response given by the V1 and V2. If this it follows this, we can say this is the linear circuit. Otherwise, it is non-linear circuit. Now another is the time variant, means invariant circuit. Means it doesn't depends upon the time. Time variance means depends upon time. Suppose I am applying here, say suppose I am applying the voltage V to the resistance, and the circuit is closed now. Now the circuit is time invariance. It means that whenever time is changes, suppose I am applying voltage for 1 second, or I am applying voltage for say 10 seconds. 10 seconds. Suppose voltage is suppose 5 and the resistance is suppose 5. So what is current? Current I is equal to, current I is given by 5 upon 5. That is 1 ampere, right? 1 ampere. Means if we applied 5 volt for 1 second, current is 1 ampere. If we applied 5 voltage for 10 second, current is also 1 ampere. It means that it doesn't depends upon time. That means this resistance doesn't change with respect to the time. So if this circuit, such circuit is there, you can say it is time invariant circuit. It varies with the time, so we can say that is a time variant circuit. Now another circuit that is known as passive circuit or active circuit. Now passive circuit has say property of passivity. Passivity means we can say that if in the network it consists of R, L and C, it consists of resistance, inductance and capacitance, then it called passive circuit. Now in passive circuit there is no voltage source, no energy source is connected in some circuit. So the circuit or this network is known as passive network. Now the question may arise in your mind that we know that L and C is known as energy storing elements, right? So when we applied voltage with the inductance or voltage connected to the capacitor, it stores some energy. So I'm talking that I'm saying that the RLC is the passive. Passive means doesn't give any supply, doesn't give any source of supply. But in case of LNC, we know that this is an energy storing device. So when we applied some voltage to the circuit, the LNC stored some energy. So we can say the circuit is active circuit. In active circuit, we have components as well as source also. So if source is connected to the circuit is known as active. Source is not connected to the circuit is known as passive circuit. But in case of inductor and capacitor, we have some energy stored in the inductor and capacitor. But this inductor and capacitor doesn't give some energy, because it gives some energy without we know that when external source is removed, so L and C will give the source of energy whatever stored in inductor and capacitor, that will be given back to the circuit for a moment of time, not for a continuous. Because whatever the energy stored in inductor, we know that energy stored in inductor is 1 half Li square, and energy stored in capacitor 1 half Cv square. So we know that energy is there in inductor and capacitor, but it doesn't give energy continuously to the source, because it gives energy to the circuit for a moment of time, that is discharge of inductor, and that is known as discharging of capacitor, and that is why it is known as passive network. because it gives some energy. But if energy gives for a continuous process continuously, then we can say this is known as active circuit. So normally that whenever the RL and C is only connected in the circuit, that network is known as active network, passive network. And the sources are also connected in the circuit, that is known as active network. Now there are two types of network, active and passive. Now reciprocating networks. Now reciprocating process, that is also we have to study reciprocating theorem also. It is also very important. Now in reciprocity property, which is known as, before we I just explained with reciprocating theorem, I am giving two element, that one is known as source, that is known as source, and other point other word, that is known as response, right? Response. Now if we applied voltage and if we find current in any branch or voltage in any branch, this is no, because of, suppose voltage in any branch V1, voltage in any branch V1, any branch V1. So what happened at that time, suppose current is I, so this current because of this source, this current because of the source, right? That means when we applied voltage, the source is I. So suppose we have the circuit like this, for example, I am giving one simple circuit, say this is the source, this is resistance, one more resistance, and this is one more resistance in the circuit, one more resistance. This is simple circuit I am drawing with all resistance R1, R2, R3 and R4, and voltage is V1. Now suppose you want to find out current in this branch, that is known as suppose I, right? So when you supplied this voltage, connected voltage to this circuit and find out current, because these two are connected in series, this with the parallel and with the series circuit, series parallel combination, you can find out total current in this branch I, and you want to find out current in I1. So division of current theory, you can find out the value of I1. So this is case 1, when we connect voltage in this position. Now I am just changing the circuit like this. This is known as source, right? S, and this is known as response, R. This is known as source S, and this is known as response R. So this response because of this voltage source. Okay, so I'm just changing the position of source and response. I'm interchanging the position of source and response like this. Suppose this voltage, I'm removing this voltage from this position. So this is a simple circuit, like I'm just drawing this circuit simple by changing simple. I'm just changing the position of source and response, right? I'm connecting supply here and I'm finding source here, I, response I in this branch. That means this is the voltage V that I've interchanged. This voltage is connected, source is connected in the place of response, and response is connected in place of source. That I am changing. I am changing current I here. I am changing I1 here. This is I1. This is I1, right? I1. This is I1. I'm just this is I1 and this voltage. I'm changing source and response. Now the reciprocity theorem says that whenever I am changing the position of source and response in any complicated or any circuit, the change, the ratio of source to response or response to source, that this is R to S, that is this response is known as alpha, right? So alpha is given by response to source ratio or source to response ratio. It always remains constant. Suppose I am finding here I1 upon V1. So I am getting some value I1 upon V1, and I'm finding out I1 upon V1 in second case also. So I'm finding one more value. So this both alpha 1, alpha 1, 2, that is in one position, and then I have to find out alpha 2, 1, that is in second position, that is for this circuit, alpha 2, 1. So that it should be equal, that alpha 1, 2, it should be equal alpha 2, 1. Suppose I'm just giving, suppose this voltage is 5 volt. You just take a picture of this circuit. Just I'm just giving the value. Suppose this is 1 ohm, this is 2 ohm, this is 2 ohm, and this is again say 2 ohm. This is 2, sorry, 2, right? So this is 1 ohm, 2 ohm, 2 ohm, and 2 ohm, that I1. So you have to find out I1, then take ratio of I1 to V1, that is known as alpha 1, 2. Now you have to take another case. Here I am just changing the position. I am connecting voltage V1 to this side. After this 2 ohm, I am connecting voltage here, and I have to find out current in this branch. Now find out the current in this branch with the same value, because here voltage is 5. Though then resistance values are given. This is 1 ohm, this is 2 ohm, here is only one resistance. This is 2 ohm and 2 ohm resistance. So you have to find out the ratio of alpha 2, 1. If this alpha 2, 1 is equal to alpha 1, 2, then this circuit is known as reciprocating circuit. It follows the principle of reciprocity. Means, in conclusion, I am saying that the property is known as reciprocating theorem if the source to response or response to source ratio remains constant irrespective of interchanging the position of source and response. So I'm just reading this statement. Some network having the property that response produced at one point of the network by exciting acting at another point of the excitation, and the response are interchanged with the proper polarity, and excitation and response, it remains constant. That means the circuit or network is known as reciprocating network if the source to response ratio or response to source ratio remains constant. This is regarding the reciprocating theorem. Now I have to one more circuit network is known as lump network and distributed network. Now the word lump, and this is distributed. Lump in it, when lump means at one place, at one place, and distributed means at different place, right? The distributed means a different place. This is the different place, at different place, different place. So how can we define this lump, and what is the importance of lump parameter and distributed parameters, or lump network or distributed network? That is, this is given by this. I have to explain with our electrical circuit. Now in electrical circuit, we have like transmission line. I am just drawing here one transmission line. So this is sending end voltage, that is given by torrent power, and this is the receiving end voltage, that is we are getting, that is domestic, and in between this is the transmission line T, transmission line. So this transmission line have parameters R, L, and C. Because inductor R, this is the resistance of the circuit. Inductor is the, because of mutual effect, inductor is produced, and because of this two line, suppose this is the ground line, and this is phase, and this is phase, and this is neutral. Suppose this is phase and this is neutral. So in between the capacitor forms and will affect the circuit. Like this is the capacitor in between. So capacitor, I just have to draw the capacitor. So this capacitor is in between. Suppose this capacitor between these 2 points, because these both are at different potential. We know that when two different potential plates are parallel to each other, it form a capacitance. So it form a capacitance, right? Now because of mutual inductors, because both two conductors are placed nearer to each other, it produce EMF in the other circuit. So because of that, it produce inductor L. And resistance, as usual, resistance is offered by the transmission line. Normally it is very small value, so we can neglect the resistance in actual analysis. Now this circuit, we know that this is a single wire, one wire having certain length of the wire, certain length. Now this wire has different parameters: resistance, inductance, and capacitance. So because of this, we have Z, that is known as impedance of the circuit, which is given by the combination of RLC, R, L and C, that is impedance. And because of this impedance, there is a voltage drop that is known as VR, which is given by I into Z. That Z is given by the total admittance of the transmission line, impedance of the transmission line, right? Now this resistance is distributed. We know that this is the distributed resistance. Inductor is also distributed and capacitor is also distributed. So for the analysis purpose, we have to assume that these all parameters are at one place. So I have to, for the analysis purpose, we have you have to study such type of analysis in your next semester. But I'm just giving a simple circuit diagram. Suppose we have say this is impedance. Like say this is one impedance Z. Right, this is one circuit, and this is one capacitance. This is the capacitance, right? And this is the circuit. Suppose I am just drawing the circuit. This is sending end, and this is receiving end. The same circuit I have produced here. So this is the capacitor offered. This is the inductor offered by the circuit. We have neglect resistance for the analysis purpose. So what we have done, we have lumped all parameters. This is known as pi. We can say this is act as a pi. Both side capacitor, one bit in between inductor is there. There are two types of analysis: pi network and T network. But it is not required to know right now. So I'm just giving. So this parameters we have. We can say that this is the lumped parameter. We have already said that this L is the L of whole line. This both capacitor is the capacitor of this whole transmission line. So if we many device, now I'm just reading this sentence now. So this lump and distributed network, which is used in power system analysis, that I already explained. Many devices in the electrical system are distributed in the space like this, right? So transmission line, winding of the transformer, generators are distributed in the similar manner. So whenever the devices are energized, the effect is not experienced by the line length or winding length, but instantly because of the finite velocity of the electrical signal. Because when the signals are moving from this place to this place, it offered resistance for this small portion now, then after it increased resistance, now inductor and capacitor. Because the effect are changes, it will take some time. So because of that, if you want to, hello, please mute your sound. Hello. Now, however, if we interested in the steady state analysis means what happened with the circuit for a long time. When we connect the circuit to the power system for a long time, what happened? So for that, we have to find out the parameters R and C, R, L and C to be lumped rather than the distributed, because distributed parameters are difficult to sort because the transmission line length is very large length of the transmission line. So we have to assume that these all parameters are lumped at one place. So lumped at one place like this, that is known as the lump parameter, and such network is known as lumped network. And if the network are distributed parameters, so this is known as distributed network, right? Now another circuit network which is known as unilateral network and bilateral network. Unilateral network means in one direction, and bilateral network that is known as both the directions. Means in the both the network, we I'm just giving two example. One example is known as transmission line that I already given. So this is sending end voltage, this is receiving end voltage, and this is impedance. Now if we applied voltage from this side, you will get voltage at this side. Now I'm reversing this, I'm giving the voltage this side and I'm getting the voltage here. So there is no difference because this impedance offered the same impedance as we interchange the position of sending and receiving voltage. Means the performance of the transmission line is same in both the direction. So such network is known as bilateral network. Means the performance of the network is same in the both the direction, which is known as bilateral network. Now unilateral network, I am giving example of unilateral network, that is known as rectifier circuit. Suppose this is a rectifier circuit that you have already studied in first year, that is half wave rectifier and full wave rectifier. So I am giving input that is known as AC. So I am giving output here. Sorry. This I am getting output here. That is known as DC. Right. So I'm giving input to this terminal, I'm getting output to this terminal. But reverse is not possible. Suppose I'm giving AC to this side, I'm not getting DC. Right. Suppose I'm giving DC to this side, the circuit will damage. So this circuit is known as unilateral network. So we have two types of network, that unilateral network and bilateral network. Right. Now we have to study this all regarding the different types of network that already we have studied. So I have already given the tutorial, and in tutorial I have given a question also, said what are the different types of network. You have to solve this tutorial after completion of the study, right? Now
Hello
the
sir.
source, hello.
પ્રેઝન્ટેશન લેક થાય છે સર, તમારું પ્રેઝન્ટેશન બહુ જ ચોટે છે.
ચોટે છે પ્રેઝન્ટેશન.
હા, વચ્ચે વચ્ચે બ્લેન્ક પેજ આવી જાય છે આખે આખું.
અચ્છા, અત્યારે સોર્સ ઓફ એનર્જી દેખાય છે?
જો અત્યારે થઈ ગયું છે બે. હા જો સર થાય છે લેક.
અચ્છા, એકચ્યુઅલી થોડો નેટવર્ક ઇશ્યુ લાગે છે. બધાને પ્રોબ્લેમ આવે છે કે તારે એકને જ આવે છે?
અવાજ કટ હોત થાય.
હું તો સ્વાઈપ
બધાને આવે છે, દેખાય છે બરાબર. સોર્સ ઓફ એનર્જી
અવાજ કટ થાય છે સર.
હા હેલો,
બધાને કટ થાય, વિડિયો કઈ આખું આવતું નથી.
એકચ્યુઅલી છે ને થોડો નેટવર્ક ઇશ્યુ આજે શરૂઆતમાં જ પ્રોબ્લેમ થોડો થયો હતો નેટવર્ક ઇશ્યુનો, એટલે આપણે થોડું ધીમે ધીમે સ્ટાર્ટ કરીએ. ધારો કે અત્યારે સોર્સ ઓફ એનર્જી દેખાય છે અત્યારે?
યસ. ના સર, લેક બહુ થાય છે. તમે બોલો છો ને ત્યારે જતું રહે છે, પછી પાછું આવી જાય છે.
યસ સર.
એટલે હું બોલું છું, હાલો હું બોલું છું, સંભળાય છે તમને?
હા હા
તમે બોલો છો એ સંભળાય છે, તમે જ્યારે બોલો છો ને ત્યારે પ્રેઝન્ટેશન લેક થાય છે, પછી પાછું આવતું રહે છે ઓટોમેટિક.
અચ્છા એવું થાય છે, ઓકે. એક મિનિટ હું ફરીથી પ્રેઝન્ટ કરું છું, એક જ મિનિટ ચાલુ રાખજો. I will restart this presentation. Okay. Actually network થોડો પ્રોબ્લેમ તો છે. હેલો, સંભળાય છે હવે? હેલો, સંભળાય છે? હા, તો હવે હું ફરીથી પ્રેઝન્ટેશન સ્ટાર્ટ કરું છું.
યસ સર.
ઓકે
ઓકે.
Now it is visible. It will easily after some time.
No sir.
હવે
Yes yes.
ઓકે.
બીજા સાઉન્ડ મ્યુટ કરી દો પ્લીઝ. એક જ જણ ચાલુ રાખે ખાલી. હા, હવે સંભળાય છે? હેલો.
यस सर.
ઓકે.
हाँ सर.
I will start now.
चैट बॉक्स ऑन करना पर.
શું કરું? આ બંધ કરું. ઓકે.
चैट बॉक्स.
ચેક બોક્સ. હેલો. ચેટ બોક્સ ઓન કરું. એક મિનિટ હા. એકચ્યુઅલી રિસ્પોન્સ થોડો ધીમો છે ને એટલે પ્રોબ્લેમ થાય છે આમાં. અત્યારે સોર્સ ઓફ એનર્જી દેખાય છે બેટા?
यस सर.
यस सर.
હે? હેલો.
यस यस.
ઓકે. આ તો હવે હું સ્ટાર્ટ કરું છું, બરાબર? તમે લોકો સાંભળો. ઓકે, આઈ વિલ સ્ટાર્ટ. ઓકે. Now the next topic is the source of energy. Now the source of energy, that is, we have two types of source. One source is known as independent source. Independent source means doesn't depends upon the other parameter of the circuit. That is known as independent source. Now independent source, in that independent source we have two types of source. One is ideal source, that also you might be studied in first year. So ideal source, it means your internal resistance of the source is zero. That means whatever the voltage here in the source, the same voltage will get at this point V. Means internal resistance is zero. Now, but this is not possible actually. The all sources are known as the practical sources. So if I plot the graph, like say I just plot the this source, so this is V. Okay, now as this voltage, so it remains constant. The voltage remains constant, like same straight line, because here when we load the any circuit, the voltage remains constant because the internal resistance is zero. But in actual it is not possible. So when we connect a practical source, normally all sources are known as the practical source. So this is known as voltage source. So voltage source can be represented with the voltage V, with this, and I have to write plus. Suppose this is a DC source, so I have to write plus and minus here, and this is the R. R is the Ri is the internal resistance. So what is the voltage across this terminal? Voltage across this terminal is equal to this voltage minus the voltage drop in the source, right? So this is not a constant value. It will drop like this, slightly drop. This is ideal case, this is a practical case. So this is all regarding the practical source, independent source, current source, voltage source. Now current source can be represented with the help of this. This is the equivalent circuit of current source. Current source. So the ideal current source can be represented that R in. R in means the R internal, which is equal to infinite. While in case of voltage source, your internal resistance is zero. And that is why, suppose we connect this voltage source, we have to remove this voltage source, we have to short, because there is an internal resistance is zero. So when we remove this, we have to replace this the voltage source with the short circuit. That will be studied in our previous next lectures as and when required. So you have to remember one more thing, that internal very low resistance. So internal resistance is a very small resistance. It is nearer to zero, but it is not exactly zero. While in case of ideal current source means it is represented by this round and arrow inside the which shows the direction of the current, and this R in, that is R in, which is given by the internal resistance R in. So the internal resistance of the source is always infinite in case of practical. So we can say that I is equal to I. Is equal to I. Here the current is same as the current here. There is no current passes through this branch because it is infinite resistance. But in actual it does not happen so. It is not infinite. There is some finite value. So there is some volt current, very small amount of current is passes through the R in. Though this is all regarding independent source. It doesn't depends upon, it is constant source. We can say this is constant source. It doesn't depends upon other parameter. Now another source which is known as dependent source. This is dependent source. Now this dependent source which depends upon some other parameter of the circuit and which is given by there are different dependent source are there: voltage controlled voltage source, current controlled voltage source. There are two types of voltage source: dependent voltage source, that voltage control, and current control voltage source. Means this voltage source are controlled by the voltage of another uh, voltage of another component, and same current source, this voltage source can be controlled by the current in the other circuit. That is known as current control voltage source. Now another is the current source. So current source means current control current source and voltage control current source. Now both are the same. Here is a voltage control voltage source, current control voltage source, and here is the voltage control current source and current control current source. Now this current, the dependent source, it represented by the square like this, right? So that I already shown here. Now we can say that this circuit, which is equal to mu V1, where mu is the factor depending upon the circuit components. So I will show you exact example. I will take the example when we start with the analysis of superposition and this mesh and node analysis. Now when mesh and node analysis will be taught by the NN Shah sir after this lecture. You have to join with the NN Shah's lecture after this lecture, and it will explain. He will explain in explain this mesh analysis and node analysis, right? So today we'll discuss with this, because in your syllabus you have to study, you have to solve the problem of node analysis or mesh analysis with the help of this dependent source. Independent source also you have to solve, but the dependent source you have to find out the you have to analyze the circuit with the dependent source, that voltage dependent source, current dependent source, and voltage dependent current source, and current dependent current source. So we have three voltage source. This is voltage dependent voltage source. Now here you can observe this Rm into I, means this is the voltage source. How can identify this is voltage source? Because I have written plus and minus inside, right? And here this is the current source. So how can I identify? I have make arrow instead of plus and minus. If plus and minus is written, you can say this is the voltage source. And now this equation, suppose this is the equation, is known as mu V1. Mu V1 means it depends upon voltage. And this Rm is the factor. This is a constant value. Now this I1, that is known as current dependent voltage source. This is the current value, and this is because this is depends upon I, this current. This source depends upon this current, and this source depends upon this voltage. Means as this voltage changes, this voltage also change. Same way for the current source. Now I can say this is the current dependent. This is known as current dependent current source, and this is known as voltage dependent because it is V1. It is I1. So this source depends upon I1, and this source depends upon V1. That voltage V1 I have to written here. So because there are four type of sources, which is known as voltage dependent source and current dependent source. Now most important, I already this tutorial also I already given on my blog also. This is available. So now what you do is you have to solve this tutorial 1 and 2, whatever the question I have given. Now this is a very important point that we have to. I'm just giving basics of this because the time is up now. So now dot conventions for the couple circuit. Now you might be knowing the magnetic circuit. Now what is magnetic circuit? I am just explaining by some giving some say this is some coil like this. This is coil. You already studied, right? This is simple, cool. Now I am applying voltage V1 here, so I am getting V2, right? This is the voltage V2. Now this is primary circuit, this is secondary circuit. Now we know that in between there is no electrical connection. Only this will show, this two lines will show the core, which is known as core of the material. Core. This is known as core. Now same circuit I am just the same circuit I have shown here. This is known as electrical circuit. This is known as electrical plus magnetic circuit. Now this is one circuit number one, that is N1. N1, this is N1, this is N1, this is N2, N2, sorry, N2, and this is also N2, right? So when we applied the voltage V1, there is no electrical connection in between. We know that because this is the circuit closed like this circuit is closed like this. Okay, so there is a magnetic circuit in between. So this what my mouse is when I am rolling the mouse, which is known as the core of the material, right? So this is the two line I have shown. This is the symbol and this is the actual representation. So whenever I am applying the voltage here, I am applying the voltage V1, that is known as VT, and I am connecting the circuit with the coil like this N1, coil N1. So when I wound this coil with the number of turn N1, right? So we have a basic equation, magnetic equation that who are familiar, that N phi. What is N phi? Is known as the magnetic flux linkage, N phi, right? So N phi, which is known as, suppose I'm just want to find out MMF, that is magnetomotive force. That already you have studied, and in magnetic circuit we have magnetomotive force, and in electric circuit we have EMF, that is known as electromotive force. Now so this N phi is the flux linked with the winding. Now whenever current passes through this coil, it will produce flux like this MMF. This is the MMF. MMF is given by this N into I. This is the flux linkage and this is S. S is the reluctance of the circuit, right? So I can find this circuit N phi upon reluctance, this flux upon reluctance. Sorry, this I have to remove this because just a minute, I'll make some mistake. MMF is given by N into I, number of turns into I, number of turns. We know that this is the number of turns, that is N1 is known value, this is N1, this N1 into I, right? N1 into I. N1 into I. Now N1 into I is known as MMF. Now when we applied the voltage here, because of the current I1, suppose this is current I1 and number of turns N1, so N1 into I1 is the MMF, right? And we know that the reluctance of the circuit, reluctance of this magnetic, when we talk about the electrical circuit, it is known as resistance, and when we talk about the magnetic circuit, it is known as reluctance, which is given by L upon mu 0. That is mu 0 is the mutual that is known as permeability, mu 0 mu r, mu 0 mu r, sorry, mu r. Here is the mu r, is the mu r. L upon mu 0 mu, L upon mu, you can say mu is equal to mu 0 mu r. So this is the L is known value because the length is known, length of the path is known, mu is known because mu 0 and mu r is given. So reluctance is known, MMF is known, so you can find out flux. That flux is given by MMF mmf upon reluctance. That is same as electrical circuit. I already analogy with the electrical, that is known as V upon R. So V, instead of V here is mmf, instead of R here is the S, and that is reluctance, and instead of I we have flux phi, right? Now this flux phi is produced, which is linked with the winding. This flux phi linked with this winding, right? Now we know that the Faraday's law of electromagnetic induction, that EMF is induced, E, in the circuit is known as rate of change of flux linked with the winding. That means it is given by n d phi by dt, that is known as d phi by dt, d phi by dt, that is minus n d phi by dt. That n I have to write down here, n d phi by dt. So this EMF, that is known as EMF produced, this EMF is produced because of the magnetic circuit, because of the magnetic circuit, because there is no electrical connection in between. So this EMF is known as mutual induced EMF, mutual induced EMF. Now the same flux will link with this winding also. So one more EMF is induced, that is known as E1. This is known as E2. This is known as E2, right? Or we can say that this is E1. So this E1 is known as self-induced EMF. That is also flux linked with the winding with this chain. So this EMF is induced in the winding, first winding, E1. This voltage, this is known as voltage applied, and this is known as induced voltage. That voltage is produced because of the magnetic circuit. So because of this magnetic circuit and this N1 and N2, voltage is produced in the circuit. Now this, whatever the voltage produced in the secondary circuit, it depends upon the self-induced self-inductance and depends upon the mutual inductance. So the self-inductance and mutual inductance depends upon the mutual coupling between. So this is known as coupled circuit. Coupled circuit. So the EMF is induced in the secondary circuit. It depends upon the direction of the current passes through the winding in the first winding, or direction of the current in the secondary winding. So we have to link with I1 and I2. That linkage of I1 and I2 is known as the dot convention. The linkage of I1 and I2 is known as the dot convention. What is dot convention? That will discuss in our next lecture, right? So this is the basic of the magnetic circuit. That dot convention we will study it in our next lecture, that we will discuss in the next lecture. So today's session we will close, but just a minute, you don't leave, because I have to give some instruction to the students. Please don't leave.